Hi class, today's lesson is part 2 of dimensional analysis. The learning outcome for today's lesson is to construct an empirical equation using dimensional analysis. This is class by Raj, teaching for Physics Form 6 Semester 1.
For our next lesson is we want to construct an empirical equation by using a dimensional analysis. Now what is an empirical equation? Empirical equations are equations that is derived from the experimental observation rather than theory. Okay? So dimension analysis enables us to construct an equation that relate a physical quantity to that variable that are observed in experiment. Now let's look at an example of an experimental observation that is done. From an experimental observation, they found out that the period t of a simple pendulum depend on its length and the acceleration due to gravity. So this is an observation from an experiment. They found out this. The first thing we do is class, we try to find the quantity in this sentence. The first quantity is the period t. The second is the length. And the third is the acceleration due to gravity. Okay, so I'm going to just explain it on this paper here. Okay, so we know that the period t is of a simple pendulum depend on its length and the acceleration due to gravity. So it depends on length and then acceleration due to gravity, which is g. So what we do is at this length here we put an index which is a dimensionless constant or non-dimension constant, dimensionless. Here we put x, here we put y for g. Okay, because we want to know how much they are related to each other. Okay, and this x and y, they are dimensionless constant. You can also put any alphabet that you like. Alright, so then next what we do is that we change this into a mathematical form, which is to the equal form. So when you change it to the equal form class, you have to put a dimensionless constant, which is a non-dimension constant. Okay, which I'm going to put k. Every time when you change a proportional sign to equal sign, you have to do so. Then I put L, X, G, Y. Okay, so the next process is, it is known that I'm going to find dimension. So what I do is I have to put a bracket. This is the right way of doing it, class. Okay, so then it will be known that the next process is to find dimension. Okay, this is not simple like any maths, yeah. So the physics way is the way of doing it right. Okay, so when I see this kind of bracket, that means I have to find dimension. The dimension of period is like time. So the dimension of period is time. So we put t. Okay, and then the dimension of k. K is a non-dimensionless constant. So we say that k has no dimension. Alright, so L, the dimension of L. L is length. So the dimension of L is capital L, and then we put x. The dimension of g. G is acceleration due to gravity. So it's still acceleration, right? So is L t negative 2. Then I put y. Okay, then what I do is that we know from our mathematics, this is your physics, now it's your maths. So this is t, that means it's t1, correct? Alright, so what we do is that we equate the dimension of both sides of the equation. We equate it. Okay, so we're going to take I'm going to take t first. Okay, alright, so here before I do that, I'm going to just simplify it so you can have a clearer picture here. Lx, Ly, t negative 2y, correct? So it's actually this y is also here involved, yeah. So t1 and t negative 2y. So I'm going to equate both sides. So when I'm going to equate both sides, so t1 equals to t negative 2y. We bring all the base together. In maths, the base together, so the index will be equal. So 1 is equals to negative 2y, y is negative 1 over 2. And then if for L, okay, this side of this equation, since there is no L, so it's considered to be L to the power of 0, correct? L to the power of 0 means is 1. So here I can say L0 is equals to Lx Ly. So base times index will plus. So 0 equals to x plus y. So x equals to negative y. So x is negative, negative half, x is half. We haven't finished yet. Okay, our mission is to find the, or is to construct the equation. So we haven't construct yet. So what we do is we bring back our answer to this first equation here. So t is equals to k, a non-dimensionless constant. L, x is half, g is negative half. And I rearrange it. I can rearrange it like this, or I can rearrange it like this. Okay, so now we already construct the equation that relates the physical quantity to the variable that are observed in experiment. You are given a statement and now you already construct an equation. Now the value of k can be determined experimentally. Alright, so this is how to construct an empirical equation using dimension analysis.